A wheel 31 cm in diameter accelerates uniformly from 240 rpm to 360 rpm in 6.8 seconds. How far will a point on the edge of the wheel have traveled in this time? So first of all, we have motion with acceleration, uniform acceleration. So first we have to find our angular acceleration. To find angular acceleration, we will use definition of this. It's omega final minus omega initial divided by delta t. Now, we have both omega final and omega initial, but we have this in RPMs. We have to convert this in radians per second. So first of all, I will take final 360 RPM, subtract 240 RPM. We will have how many revolutions per minute we have. Then we have to convert this in radians per second, so we have to multiply this by 2 pi and divide it by 60, and we will have radians per second. Then you have to divide this by 6.8 seconds, and this is your alpha. Now, if you know alpha, you can calculate through what angle the wheel will rotate, and the point on the wheel will rotate as well. So to do that, you have to calculate delta theta, which is theta final minus theta initial, and you can use different formulas for that. I will use omega initial delta t plus 1/2 alpha delta t square, for example. So what I can do, I can put here my omega initial, which is 240 times 2 pi divided by 60 radians per second, multiply by the time interval 6.8 seconds. Then I have to add plus 1/2 alpha. Alpha you have, of course, to calculate first. Without that you cannot do that. And then I will put here 360 minus 240, 120 times 2 pi divided by 60 radians per second divided by 6.8 second times 6.8 second square. This is angle through which the point on the wheel will rotate. And to find the linear distance, the only what you have to do is you have to use connectionship which exists between length of the arc and angle. This relationship is very simple. Length of the arc is equal theta times radius. So the total path covered by the point on the edge of the wheel will be half of the diameter, 31 centimeters divided by 2 times 0.01 meters to convert into the meters, and then you have to calculate by your delta theta. And delta theta is given by the expression above. So you multiply that by delta theta. If you will do all calculations correctly, you will have about 33 meters. I believe it's slightly less, but this is a good approximation. We did solve this problem.